Now in this video I will tell you about how to analyze the building under seismic load. So we will first define the load pattern. So go to define and click load pattern. Here write earthquake load or seismic load. I write earthquake EQ and type as seismic, and in the option of lateral load we have to choose the code IS 1893 2002 and then add new load. In the earthquake load we have to modify lateral loads. So in this we will consider the seismic waves in X and Y directions. So for this problem we will uncheck the eccentricity. Only the seismic waves will be along the X direction and along the Y directions. So in the seismic coefficients we have a seismic code which depend upon the zone. So in this problem the building is to be designed for Bangalore. So from IS 1893 we can see that the Bangalore is present in the zone 2. Here the Bangalore is present in zone 2. So we will select zone 2, and for zone 2 we have the zone factor, seismic zone factor. In table 2 we will get this in IS 1893 in table 2, that the seismic zone factor for zone 2 is 0.1. So we will select this 0.1 and site type, and for the site type again we will go to the IS code. Here type, there are different types of, like if we have a soft soil then it is a type 3, if we have a rock or hard soil then it is type 1, and if we have a medium soil then it is type 2. For our problem it is type 2, that is the soil beneath the structure is of medium soil, and therefore we will select type 2. And importance factor, if for importance factor also we will take it from the IS code. We'll go to the IS code, and here in table 6 of IS 1893 we will get table 6 importance factor for the buildings like hospitals, schools. It is 1.5 for the residential buildings. Like in our case we will have the importance factor equals to 1. So we'll set this importance factor is equal to 1. Now the response reduction factor will take time period as a program calculator. It will be calculated by the program, and the response reduction factor we will also take this from IS code. Again we will go to the IS code, and in this, in table 7 we will get of IS 1893 that the building frame system for ordinary reinforced concrete moment resisting frame, the R value is 3. For different types of you will get all these, but in our case it is reinforced concrete so structure. So we'll take a R value equals to 3. Now the R value will be 3 and click OK, and then again OK. Now we will define the load pattern. So go to define. So sorry, we have defined the load pattern. Now we will do a load combinations. So we will go to load combinations. Here there is no load combination added, so we will click add default design combos, and we will check the concrete frame design and click OK. Now these are the 8 combinations we get. You can see that if we are on the arrow that the first combination is 1.5 dead load, second is 1.5 dead plus 1.5 live, third is 1.2 dead load plus 1.2 live plus 1.2 earthquake, then minus 1.2 earthquake, and 1.5 dead plus 1.5 earthquake, 1.5. In this way you can get all the combinations which are possible for dead, live and earthquake load, and in this way you can do the load combinations and then click OK. Since the earthquake load has been assigned, now we will analyze this structure. Since in this problem we have applied the wind load also and the earthquake load also, so for analyzing it, for the earthquake load we will not run the analysis for the wind load. So when we will go to analyze and set load case to run. Now for this wind load we will click here and do not run. Now the analysis will not be run for the wind load. So now click run now. The analysis is going on. You can see the status here. Now the analysis has been completed. You can see the maximum displacement and the minimum displacement at the different locations. Now you can see the analysis result from here as a display, deform, shear, force, stresses diagram, like support reactions, frame and shear stresses forces. You can see like, or you can choose the combo, which combo you want to know the reactions and moment shear stresses. So I let it be dead load. I want to see. I choose a moment M22, then I will apply. Here you can see the moments values, how they are coming. You can also see this in the 3D view by clicking this and applying. So in this way you can interpret the analysis result. But now we are going to close this and run a design for run the design for this. So we'll go to design, concrete frame design, revise, view and revise preferences. For this we will set the design code as IS456. Check this, make sure that the design code is IS456 2000, then click OK. Now go to design, concrete frame design, and you can also check the design combinations that have already been set here and click OK. And for this you go to design, concrete frame design, and start design / check. The designing process is going on. Now you have get that analysis of design section differ for 8 concrete frames, means that 8 concrete members are failing. So as we have done this designing on the basis of auto select list, so we will reiterate the analysis so that the software will remove these 8 concrete and replace these members as a higher section members. You have to do this again and again till you get the message of all the members pass. Now there are 7 members. Again click yes. Now we'll go to design and concrete and verify all member pass. Here we'll get the message of all concrete frame pass the design check and click OK.